second remedial measures will be to redesign the regression model, and in redesigning the regression model, there's no definite rule for this method, and it depends on your readings and literature review and knowledge and theory behind the model. So example here, the regression model whereby y is the fish amount, average pounds of fish consumed per capita is in kilogram. Okay, and then basically this is the consumption, and then it's a function of the price and other goods price, which is the beef, and this is the disposable income, and we have number of ocean pollution, and this is a dummy variable. So regarding the signs of the coefficient, we can expect that the sign for PF will be negative, and this one is in theory, in whereby if price increases then consumption decrease, and this one is beef, and then for beef is positive, we expect it positive, and this one positive because income, as income increases, consumption also increases. And for beef, just now positive, we expect if price of beef increase, uh, the quantity for beef decrease, and then people will buy more fish, so the consumption of fish will increase. So this means that it's a substitute good. We expect that fish is a substitute good for beef. And then we have this number of pollution and also the dummy variables. However, when we do the regression from the estimation, we found out that the signs are unexpected. So if you look at PF, the sign is positive. So this is really violating the theory itself, whereby it should be negative here. And then if you look at the R squared here, this is almost quite high, 0.73. And if you look at the t stats and you look at the p-value, all of the p-values are higher than 0.10, means none of the t-stats is significant. So signs are unexpected, t-values are insignificant, quite high in terms of the r squared. And if you look at the f-stats here, 10.57, the p-value is very small, so meaning here if we do the overall significant test, we will reject H now, meaning jointly all the variables does affect Y. So that's one of the indication there might be the problem of multicollinearity. And if we look at the zero order correlation, meaning even if we are having five independent variables, so we can look at all the correlation example between PF and PB, PF and YD, PF and N, PF and P. This is YD and N. Okay. So example here, if you look at the correlation is high, 0.92. Here we have 0.88. Okay, and still we have here 0.82. 0.91. So there's an indication of high zero order correlation, right? And then if we calculate the VIF, so how do we calculate the VIF? It is 1 over 1 minus r squared j. So how do you find r squared j? You need to regress each of the independent variables on other independent variables. Then you get the r squared, and then you replace in the formula, and you get the VIF. So if you look at the numbers in VIF, is more than 10. So we are following Gujarati above 10. There's an indication of multicollinearity. So we have this problem. So let's look further. Okay, so if we want to drop a variable, okay, so basically if we drop a variable, we cannot drop the variable of price, definitely income, definitely price, other good price. So because this is in the theory, it's always stayed there, so we cannot drop a relevant variable. So suppose we drop n here, okay, and if you drop n, it still shows that the sign does not follow our expectation, and we see that the p-value also none of the t-stats is significant, even though we have here a significant f-test. So still it's not improving. Then one of the ways that we can think is to use a relative price. So if we use relative price, okay, our P here, uh, which is PF over PB. So suppose we have the price of fish is for 1 kilo, suppose is 4.4 ringgit, and the price of beef is for 1 kilo is 2 ringgit. So if we uh, get the relative price is 4 over 2, so you have equals to 2, so meaning that the relative price of fish is equals to 2 kilos of beef. So that is the concept of relative price. So basically it's related to the concept of opportunity cost. So these are all in basically we use it in microeconomics. So that's how you plan the theory inside the model. So when we have this relative price, we are using this PF and PB, then our regression model would be uh, the consumption as a function of relative price, and also we have the disposable income, and P as the dummy variable for red current. And if you look at the results, uh, by looking at the p-value, still showing only one of the t-stats is significant. Okay, so we do some improvement, but then still we are not very satisfied with the result. So what we can think further is maybe we can use the lag terms of relative price. So lag terms meaning it is about before time frame before, meaning that if we use lag 1 t minus 1, it is the relative price of a year before. So we might have some expectation that what we respond in this year, it depends on the relative price of previous years. So when we include in the model here, okay, relative price of lag 1 previous years, then we have this income and also the dummy variables, and the science is very nice. And then we see that all of the t-stats for the independent variables are significant. We have r squared not high, but still we can just report 68%. Then the p value here is small, so meaning that we reject h null here. So the overall jointly all the independent variable does affect y. So this is kind of output or estimation that we can use in our report. So this is like an accepted estimation rather than the first and second just now. The third remedial measures would be use of priori information from previous empirical study. So we might be using results from census study, example, Banki. So example, we have this regression model consumption on income and wealth. So basically, if we think income and wealth, it is really correlated. Okay, the higher the wealth, the higher the income, the higher the wealth. So these two independent variables is highly correlated. So, but we want this in the model. So what we can do is uh, we can use a priori information whereby from other studies. Okay, so this must be really justified in your writings. So we found that beta 2 is equals to 0.1. So what we can do is we can rearrange this term beta 2 wealth, bring it to the left. So now the left side here is basically consumption minus 0.1 wealth. So we still need data on consumption, we still need data for wealth, but then we have this the left side is no longer consumption, is now another consumption, which is the consumption star causes of this. And then we regress the new consumption on income using order S. Fourth is by a transformation of the model. So suppose we have y on x1 and x2, x1t and x2t. So what we can do is basically we might expect that x1t and x2t is highly collinear. So what we can do is we can use first differencing, meaning that we are subtracting each of the term with the previous or the lag of it. So yt you need to subtract with yt minus 1, x1t with x1t minus 1, x2t with x2t minus 1. So this is a lag of 1 year, and when we have this t minus 1, this is called lag terms. So we can have t minus 2, t minus 3, and t minus 4, and so on. So this is lag 1 year. So now this is delta yt, just changes in yt from, meaning yt from yt, the value of yt minus the value of y previous year. So this is changes in yt, changes in x1t, changes in x2t, and then we can regress the changes in yt on changes in x1t and changes in x2t. Besides that, we might want to collect more data or increase our sample size. So we know that a larger sample size will basically make our estimator more precise because we are having smaller variance of estimators. So this is, even though we are doing remedial measures 1, 2, 3, but still this number 5 should be in our. We want to do this. Another way of remedial measures is by calculating the rates of change of variables. So if we have two variables that are correlated, we might calculate the rate of change, whereby to calculate the rate of change is simply by subtracting. We have y1, y2, so it's going to be y2 minus y1 over x2 minus x1 and multiplied with 100. So basically that is the rate of change for those variables. So you can use that also, even though it will affect on the error term. So this is one of the ways you can try. Last one is by doing nothing, especially if you have very low degree of multicollinearity, because we understand that it's not the issue of the presence of multicollinearity, but actually is the degree of the multicollinearity that we have. And if we are able to get a better result by changing the model specification, then it will be good to have that.